This video is going to help you remember how to do chemical reactions. And just like our last lesson about naming, this one is really helpful if you practice it yourself instead of just watching this video. So we'll go through the basics, but it's also important that you practice these reactions in your review packet. So first, let's start with what is a chemical reaction versus a physical change. So physical changes will change something about the thing without changing the identity of what it is. And some examples of this are cutting. Dissolving is one that some people have trouble with. People think that's chemical because I guess the things disappear, so they think it's a chemical reaction, but dissolving is just breaking something into really small pieces, but the pieces are still going to be in the solution. And then watch out for phase changes. So things like melting, boiling, any word that means a phase change is not changing the identity of something. So if you have an ice cube of water and you melt it into liquid water, both of them are H2O, so it hasn't changed its identity. And then you can watch out for signs of a chemical change. That is when you do change the identity. So signs of a chemical change are if you feel a temperature change on the outside of the test tube, if you feel the outside of it and it gets hot or cold, that's an indication that a chemical change is happening. You can watch out for color changes. If you mix two solutions together and they turn color, that's another indication of a chemical change. If you have two things at room temperature and they produce bubbles, so fizzing like the common baking soda and vinegar experiment, that's going to be a chemical change as well. But you do have to be careful with this because when you boil water, you will see bubbles as well. And like I said, boiling is a physical change, so you do have to be careful with that, that particular one. And then this word precipitate was one of your vocab words. A precipitate is when a solid is formed from two liquids. And the two things I want you to think about with this are cloudy and solid. So solid is formed, and the way that you can tell that it's a precipitate is that it's going to look cloudy. There are several tests that you need to be familiar with that are in our state curriculum. One is the POP test for hydrogen. And we would do this if we were in school. You would actually test it and you put the flame into the test tube, and if you hear a popping noise, it indicates that you have hydrogen. Another one is if a flame reignites easily, it means you have oxygen. So if you have a test tube full of a gas and you blow out the flame and then you put it back into the test tube and it reignites, that means that the test tube is full of oxygen. If the flame goes out, it means that it has carbon dioxide. Carbon dioxide is a very heavy gas, and so it smothers the oxygen that the flame requires for it to keep burning. And then the last one is that lime water turns cloudy with the addition of carbon dioxide. The next thing you need to know are the different types of reactions. These are in your reference packet, so you don't have to memorize them, you just have to know where to find them. Synthesis is when you put two things together. Decomposition is when you break apart something, and you might have to use your reference packet for this one because if you have a big compound that has more than two elements, you won't know how it breaks apart. So you're going to have to look at the reference packet to see what the decomposition looks like. We talked about single replacement reactions, double replacement, and then combustion is like a flame. So this is the one that requires oxygen. It's a very specific type of reaction where you have a carbon and hydrogen compound that mixes with oxygen to form carbon dioxide and water. The next thing is you need to know how to balance a reaction. So again, this is something that you probably just want to practice. It just takes some time going back and forth across the arrow to make sure that the numbers match. And the last thing that we want to talk about is predicting the products. So if you mix two things together, you need to be able to figure out, first of all, does it even make a reaction? Sometimes when you mix two things together, we get what we call a DNR, stands for does not react. So first of all, make sure you always do the positive one first and then the negative one. So when you're writing a new compound on the other side of the arrow, make sure you put a positive first and then a negative when you put them together. And also don't forget to cross your charges. If it's single replacement, what you're going to do is use the activity series, which is in your reference packet. So this is the list of chemicals. It kind of ranks them in order of how reactive they are. So once you put your charges on your 3 elements, you want to compare the 2 that are the same kind of charge. So you'll either compare 2 positives or 2 negatives, and you're going to see which one is higher on the list. And remember, the rule is that the element that's higher on the list gets to have the partner. So if it already has the partner, then that's when it's a DNR. If it doesn't have the partner, then you need to rearrange the reaction and give it that partner. And there's a whole video on how to do this. If you want to go back to your reactions chapter, you can rewatch that video if you need to. And the next one is double replacement. For this one, you're going to use the solubility rules. And this is the one where we said that if both products are AQ, that is when it's a DNR. Because they're going to start AQ, so if they all end up as AQ, AQ just means that they're a soup of ions, aqueous, and so nothing has really changed, and so that's why we call it a DNR. On the solubility rules, you do need to remember that soluble means AQ, and insoluble means that it's a solid. And again, if you have trouble with double replacement, you don't know what I'm talking about, you can go back to your reactions section for this class, and you can watch the video. There's one video that explains exactly how to do this. And the last thing for this chapter are net ionic equations. And for net ionic equations, for this class, you're going to have 2 ions coming together to make a solid. So that's basically what it's going to look like. You might have to decide which one is the solid if it's a double replacement reaction, so use the solubility rules. You can figure out which one is the solid, and then it's going to be 2 ions coming together to make the solid. And then everything that's not in that is a spectator ion. And again, there's a whole video on this if you need that. You can just go back to our last to this chapter that has that video, and you can go over how to do net ionic equations. And that's pretty much it for reactions.